Hello Year 10, hope you're continuing to stay well. We're going to continue on with density, mass, and volume today. I wouldn't necessarily say that today is a different lesson. We're just going to look at some slightly more complicated questions. Maybe they have more steps to them. Maybe you have to work forwards and then backwards. They're not particularly difficult. They're not very different from yesterday. Some of you will be able to do them without any of my help. It just is going to depend. So let's go ahead and get started. All right, example 1. The diagram below shows a solid block of ice. The block of ice weighs a half a ton. The block is a cube with a side length of 81 centimeters. Find the density of the ice. Give your answer in kilograms per cubic meter. Okay, so we want to find our answer in kilograms per meter cubed. So we have a bit of an issue. One major issue that I'm noticing is that it says half a ton. A ton doesn't sound like a kilogram, so we're going to have to think about that. And also, it says the units are in meters cubed, but the side length of this cube is actually in centimeters. So a few things to consider. So they're asking us to find the density. So they want us to find the density, which means we need the mass and we need the volume. Well, I'm going to start by finding the volume because I know how to find the volume of a cube because we've done that recently. We want this in meters cubed, so I'm just going to go ahead and convert 81 centimeters is 0.81 meters. So the volume of this particular cube is going to be 0.81 times 0.81 times by 0.81. Now, I'd love to be able to tell you that I can do that in my head, but no. 0.81 to the power of 3, which is 0.531441 meters cubed. Now, it's in meters because I converted everything into meters. Don't worry that it's a long decimal. We'll deal with that in a minute. So we found the volume. Now we have to find the mass. Half of a ton. Well, 1 ton, I don't know if you know this, is actually 1,000 k. Ooh, that's not 1,000. 1,000 kg. So half a ton must be 500 kg. And now we've got our measurements we need. We've got a volume that's in meters cubed, and we have a mass that's in kilograms. So now that we know those two things, we can actually go ahead and find the density. So the density is going to be mass divided by volume, which is 500 divided by this nice big decimal, 0.531441. It's actually not a big decimal. I guess it's a long decimal, but anyways. 500 divided by that answer, we get 940.8 kilograms per meter cubed. And I think that's all we're looking for. So find the density and give your answer in kilograms per meters cubed. Yep, we did it. There you go. So not super difficult, but things that you might not notice the first time you look at the question. All right, let's look at another one. All right, this question here, I would say, is fairly common in the new GCSE. They do like you to compare different things. This one has a lot happening in it. So Beverly is building a toy boat. If wood has a density under 1 gram per centimeter cubed, it will float. She has a choice of 3 different pieces of wood, piece 1, 2, and 3. Which piece of wood is the most suitable? So essentially what we have to do is calculate the density of each of these pieces, but they want us to compare them to grams per centimeter cubed. They've got grams and centimeters cubed. That's great. This one is not so great. We've got kilograms and meters cubed, and then again kilograms and meters or centimeters cubed. So we can do this. We'll have a go at it and see what happens. Let's have a try. So let's start with piece 1. So piece 1, they want us to find the density. So in order to find the density, we have to do mass divided by volume. So piece 1 is going to be mass over volume, which is going to give us the mass is 450 divided by the volume, which is 400. And that is going to give us a lovely answer of 450 divided by 400, 1.125. So 1.125. And that is grams per centimeter cubed. It says if wood has a density under that. Okay, so that's really not going to help us. Already I can see that this answer is not is not going to help us very much. So the reason why it's not going to help us is because it's greater than 1 gram per centimeter cubed. So piece 1 we sorted. Piece 2, it is in meters cubed and kilograms. Now the kilograms I'm pretty certain about. That is 8,000 grams. The meters cubed, there's lots of people who are really good at remembering their conversion units. I'm not that great at it. I do know the difference between centimeters and meters, so I'm going to think about it like that. If I had a little cube right here, not the best drawing, but if I had a little cube right there and all of the sides were 1 meter, then the volume would be 1 meter cubed. Okay, so if all of the sides had a side length of 1 meter, it would be 1 meter cubed. 1 meter is the same as 100 centimeters. So the volume would also be the same as 100 times by 100 times by 100, which would actually give us 1 million, because that is 6 zeros, which is 1 million centimeter cubed. Now, because 1 meter and 1 centimeter are the same, I know that these two things are equal to each other. 1 meter cubed is the same as 1 million centimeters cubed. So I can go ahead and multiply 0.02 meters cubed by 1 million, and I end up with 20,000. So this has a volume of 20,000 centimeters cubed. So now we can go ahead and find piece 2. So piece 2 is going to be, the density is the mass divided by the volume, so 8,000 divided by 20,000. Which is going to give us 8,000 divided by 20,000, which is 0.4, which is less than 1, which means it will float, but we don't know if it's going to be, oops, I made a mistake, if we don't know if it's going to be the best one that we can use. So there's our next answer. Now I'm just going to pause for a moment, and I'm going to get rid of the triangle so I have somewhere to write. All right, and we've got piece 3. The volume is in centimeters cubed, and the mass is going to be 1,030 grams. So piece 3, the density here is mass divided by volume. So the mass is 1,030 divided by the volume, which is 1,000, which is going to give us 1,030 divided by 1,000, a lovely answer of 1.03. Now we have to decide which of these 3 pieces is going to be the most useful when we're looking at finding a material to build this particular toy boat with. So the wood should have a density under 1 gram per centimeter cubed, and the only one that we have found that is under 1 gram per centimeter cubed is actually wood, or piece 2. So this one is really close. Piece 3 is really close, but it's too much. It has to be under. Okay, and then there you go. That is that question done. That is a monster of a question. Let's look at another one. All right, last example from me today. The diagram shows a solid triangular prism. The prism is made from wood and has a mass of 643.8 grams. The density of the wood is 1.85 grams per centimeter cubed. This is looking good. We've got the same units in both places. Calculate the length. Oh dear, the length of the prism. Okay, how are we going to find the length? Well, I feel like we've got to use somehow the density and the mass to probably find the volume. I think that's a good start. So if we want to find volume, we're going to have to do mass divided by density. All right, so the mass of this thing is 643.8 grams divided by the density, which is 1.85. So we're going to find the volume in centimeters cubed. 643.8 divided by 1.85 gives us a lovely answer of 348 centimeters cubed. Now, if we think back to the last topic that we did, I believe before algebra we did volume. So if we look at this triangular prism, we know that the volume is going to be the area of the face times by the length. So let's go ahead and fill in what we know. We know the volume we just found is 348. The area is the area of the triangle. Now this triangle right here, okay, remember how do you find the area of a triangle? It's going to be 6 times by 8 divided by 2. 6 times by 8 is 48, divided by 2, that's going to give us 24 centimeters squared. So the area is 24, and we want to times by the length. That's what we're trying to find. All right, so if we want to find the length, we can just work backwards and divide. So x, which we were looking for, is 348 divided by 24. And then pop over to our calculator. We get a lovely answer of 14.5. Now, I reckon that one looked a little bit fancier than it really was, but there we go. I think that's all from me today. As you know, if you have any questions at all, you can ask me on Google Classroom, or you can go ahead and send me an email. All right, have a good day, and let me know if you have any questions.